everyone, welcome you all. So I have an exciting announcement. We have arranged a networking session, post the sessions with DJ and drinks. We invite you all to join us. And now I have got two experts together going to talk about the most happening technologies, Azure Event Hubs and Azure Stream Analytics. Both Ajitha and Kevin have got extensive experience in Azure Stream Analytics and Azure Event Hubs. And I am looking forward to see how exciting the demonstration is going to be on these two technologies working together on real-time scenarios. Please join me in welcoming Ajitha Singhal and Kevin Lam. Thank you.
Right, hello, Integrate. No Rocky theme song? I thought I would get a Rocky theme song. Okay. It's fantastic to be back on stage with all of you. This is one of my favorite conferences to come to because integration is one of my favorite subjects to talk about. And the products that we talk about and drive are kind of the heart and blood of our integration services. So let's go through an agenda, what we're going to talk about today. First, I'm going to talk about real-time event streaming and what that means for your new integration spaces working in the cloud with streams. Then I'll go into Azure Event Hubs, give you a little introduction again for those that forgot or are new to Event Hubs, what we've done and what's coming. And then I'll hand it off to Ajitha to talk about Stream Analytics, and then we will do a demo with those two things together. All right. So Clemens did a great job setting up talking about events. And one of the things that we're dealing with in this era is the torrent of events that's coming in from various systems. You have devices in cars, devices in refrigerators, you have web apps emitting events, you have clickstream events, you have monetary events. So all these events are coming in. And so what we've traditionally done is taken those things and put them into databases and other types of storage, and then dealt with it as either batch processing or just referential data. And what we really want to do is to take advantage of that market is deal with it in real time. So as those events are flowing, we want to be able to handle those events as they come into the system. And Clemens talked about how you want to think about the differentiation between a time series set of events where all those events are correlated to each other versus discrete events where you want to react to those events. And so in these time series sets of events where you have all these events coordinated, you want to be able to process those events. And it's not that much different than what you're used to in classic integration modeling, where you want to have a pipeline that deals with the events that are coming in. You're ingesting them, and we ingest them with a broker, an event streaming broker. And then after they get ingested, you need to go and process it. So you need to go decode and validate it. The first thing you want to do is probably persist all those events. And Event Hubs has a right out of the box ability to put all those data into storage, decode and validate it. So then you can use Event Stream Analytics to go ahead and validate all those entries that are coming in, throw out the ones that are no good, push them onto another Event Hub that has a filtered set of events that are good. It goes to another Event Hub that does its filtering and transforms and enrichment that can then get routed to lots of different Event Hubs, which then you have different actors on that's going to go and deal with that. And it's going to go to either real-time dashboarding, it's going to go and get a materialized view into like Cosmos or SQL, or you can transform it into Parquet and Delta Lake, and then you can have data analytics working on top of that data. So this is this is actually a very common pattern that we're seeing, right? It's not I just ingest once, and then now I have the data. You want to be able to handle that data in real time as it's flowing through your system, so you're creating these streaming pipelines. And so today, we're going to talk about Event Hubs and Stream Analytics and how those things are coming better together and helps you create these types of streaming pipelines. So first I'll talk about Event Hubs. For those that aren't familiar with Event Hubs or need a refresher, right? Our Event Hubs is our streaming service, right? Our broker for handling event streams. It's highly scalable. So we can handle gigabits per second of the events coming into the system. It's highly available. So availability is in multiple dimensions. So we have multiple nodes handling all of your workloads. So then any one node failure doesn't affect you. It's one of the great advantages of having PaaS. And it's also in availability zones. So we saw that in Logic Apps and some of the other sessions where you see all the data being pushed through availability zones so you can get copies in multiple data centers. It's multi-protocol. So Event Hubs handles APIs from HTTP to the Kafka API to the native MQP protocol. It's partitioned. So one of the things that allows us to suck in that torrent of data is that we can partition those events across multiple partitions where Clemens talked about those bundles of events that's coming through. And that allows you to parallelize your consumers so that you can have multiple consumers on that same event stream. Go ahead and suck that data in through different partitions. You can also have multiple consumer groups, each having their own cursor as to where they're at in that stream. And remember, event streams is different than transactional queues, right? So event streams is a sequential set of events that's coming in that's correlated over time. And so you want to be able to read that and push to it like you're reading a tape, right? So in queues, the broker manages the lifetime of that message. Once you commit that you've read it, it gets deleted. And here it's all based on the client. So you can pull that same thread multiple times and read those messages again and again. So, there are lots and lots of capabilities in Event Hubs. Who has not used Event Hubs in the past? Okay, so about half of you. So, in Event Hubs, with it being our cloud broker, a lot of customers come to us and say, hey, I want Kafka, right? There's a lot of great advertisements out there for Kafka, and they think it's the best thing since sliced bread. And it's a fantastic broker. So one of the things that Event Hubs does for you is it provides the same capabilities as Kafka, and we have a Kafka API that allows you to do all those same types of activities that you're used to with Apache Kafka. So let's go into what's new with Event Hubs. First, Event Hubs Premium is fast. In the past 6 months, we released Event Hubs Premium, and we've done some performance testing, and we've made some improvements in the back end even since we've released it. And Clemens gave the hint that it's doing less than 10 milliseconds from end-to-end processing. So that means it's triple replicated across the different availability zones and coming back to us in less than 10 milliseconds. So those availability zones aren't within the same data center. They're 3 different data centers disparate from each other. And not only that, it's consistent. So you see that consistent 10 millisecond latency time, and compared to other Kafka brokers up in the cloud, you don't get that same consistency that you would get with triple replication and using either the Event Hubs API or the Kafka API. You see they're quite similar. So it's super fast, right? So we're not going to be your bottleneck in trying to push those gigabytes of data through our system. It's usually the things that have to go and deal with it. One of the asks that we've had for Event Hubs is the ability to throttle certain types of applications. Sometimes an event stream can be used by multiple different applications, and some applications are more important than other applications. So what we've done is we created resource governance for client applications where we're going to give you application groups. You create an application group based on a client ID or an app ID, and then you put them into that group, and you have rules in that group. You can either say that they're actually allowed or not allowed to use this particular event hub, or you can set throttle limits. So if you have a high priority clients and a set of low priority clients, then both on the producer and the consumer side, you can set and configure those throttles for those. Capture streaming Parquet. So today, out of the box, we do capture in Avro, go straight to storage to do that capture. And now the better together with ASA, we're able to do capture with stream analytics into Parquet format. Now it's important to understand why we decided to use stream analytics to help us persist to Parquet. One of the responsibilities and the premises of a broker is that the broker never touches the message, right? So our job is we don't peek inside the message and that's not our realm of stuff. So Parquet requires you to take that message, reformat it, and put it into a columnar format that then gets persisted to disk. So we need something like Stream Analytics to do that analysis of the content of the message so that I can retransform it and then push it to disk. But what we've done is made it super easy to use, and you'll see a demo that will include persisting to Parquet. And we're announcing here today that we are releasing self-serve dedicated clusters. So before today, you were required for dedicated clusters as our dedicated set of infrastructure that you can run your Event Hubs in. Before you needed to call us up if you wanted to scale it up or scale it down. So now you no longer have to do that. So we've given you the capability right in the portal to scale up and scale down your own dedicated clusters. And not only that, it's running on our latest and greatest hardware. You know, it's been years since we released this, and it gave us an opportunity to use better, faster hardware in the back end. So you'll actually see significant improvement in performance and throughput and latency with dedicated clusters. So today it's available in 3 regions, but we'll be putting into every region as soon as we can. Okay, a quick walkthrough in the roadmap. There's a number of things that we're working on. This is the next 3 to 5 months. So everything on this list, so I didn't give you the long view roadmap. First is a Kafka portal experience. So folks who are used to using and managing Kafka clusters, we're going to give you a portal experience that will allow you to feel more like you're using Kafka, right? But it's still Event Hubs in the back, but it gives you all the right terminology and administrative capabilities that you had for Kafka, except for things like manage a zookeeper. There is no zookeeper, so you have to do things like that. A data generator, one of those things that's seems obvious, but we haven't done yet, is, hey, I want to see if this thing's working. So we're going to give you a button, and an ability to send messages to your Event Hub so you can actually see it work. It'll be great once you see some of these Stream Analytics scenarios as well. Manage identity for capture. This is something we've been working on for a little bit, and that'll give you the ability to use a managed identity to talk to your storage, as well as using a storage account that's outside of your subscription that's not the same as your Event Hub. We're going to add JSON to the schema registry. Today we support Avro. We're going to add JSON to that as well. Rounding out Kafka. So the first important thing that we're going to do is support compact topics. With compact topics, then we'll have full connector support for Kafka connectors. And autoscale for Premium. So Premium we released back at the Ignite conference back in November. And so we're working on giving you an autoscale capability so then you can base it on metric rules of when you want to scale that up and down. And then Premium in more regions. So we're chasing down regions to get our Premium in more places for you. Okay, so that's the update on Event Hubs. I went a little fast because I want to make sure that we have plenty of time for for Stream Analytics and particularly the demo because it's a really exciting demo. All right, so next.
Okay, thank you, Kevin. So before I start, I want to understand how many of you have used or worked on stream processing. Can I get a raise of hands? Okay, a couple of you. And how many of you have heard or worked on Stream Analytics, Azure Stream Analytics? Oh, perfect. Okay, sounds good. So as you know, unlocking the real-time insights, and it's very critical because we need to take action on time. For example, if there are fraudulent calls or fraudulent transactions, or we need to detect and stop any overheated engine, customers demand that they want that data, actionable insights within seconds, and sometimes even milliseconds. And that's where Azure Stream Analytics come into picture. So as you know, many of you have used or heard of Azure Stream Analytics. It's relevant across multiple industries. So as you can see here, some of the examples are real-time fraud detection, or streaming ETL, or real-time patient monitoring. So Azure Stream Analytics right now is used by various customers across various industries, and these are some of the examples. Okay, I see many people taking pictures. Yes, please go ahead. These are the scenarios that if any of you have these scenarios, you can always use Azure Stream Analytics for your stream processing. Now, Azure Stream Analytics was actually announced as leader in streaming analytics in 2021 by Forrester Wave. And that is because we are designing and helping mission-critical workloads for many customers. And I'll show you a demo, and I'll talk about some of the functionalities and features that we have that are helping customers across the globe. So this is very high-level architecture of what ASA or Azure Stream Analytics is. So on the left side, if you see, we as in Azure Stream Analytics, we ingest from 3 inputs. They're called inputs because that's where we get the events from. One is IoT Hub, another one is Event Hub, and third is Data Lake or Blob. And while analyzing that real-time data, you can always bring in your reference data in the form of SQLDB or Blob. And you can always also bring Azure ML services. It's a very common scenario across multiple customers today. And on the right side, you'll see where it says deliver. That's where Azure Stream Analytics write to these services. So that's called output in the service. So for example, the first one talks about alerts and actions in Event Hub, Service Bus, or Azure Functions. The second one talks about how you can do real-time dashboarding in SQLDB, Power BI, Cosmos DB, etc. The third one is you can always do data warehousing. Fourth talks about how you can just store your real-time data. I'll show you a demo of that. And the last one is if you want to do any kind of telemetry analysis. So there are 3 main components of Azure Stream Analytics. One is input, where it gets data from. The second is analyze, which is the query, what query logic you write. And the third is where you write that process data. Key differentiator highlights, Azure Stream Analytics is productive, hybrid, intelligent, and trusted. So let's go in detail a little bit. So for productive, why we say it's productive is because you can write very simple SQL-like language to process your real-time data. And as I showed you, we integrate with 15 plus Azure services, and you do not have to write any code for doing that integration. You just drag and drop, you just select few things in the portal, and immediately you can connect to those services. Also, we have a very comprehensive authoring service, and we provide authoring in portal as well as VS Code. And we also provide debugging and monitoring in both tooling as well as portal. So you can use anything. Most used is Azure Portal today, but when customers have advanced scenarios, they also go to VS Code to do more debugging or monitoring. The second category is hybrid. So you can actually run your logic on the cloud, or if you want, you can deploy it to IoT Edge, or if you want, you can also run on Azure Stack, which is on-premise. So that's why it's truly a hybrid service. Depending on your scenario, you can run your query anywhere. The service is also intelligent. What does that mean? A lot of customers, they bring in their own ML models, and they write the SQL-like query in Azure Stream Analytics and bring in the ML models and then do the processing on real-time data. We also integrate with Azure ML, so you can write your advanced machine learning scenarios. We also have geospatial functions, and you can always do anomaly detection. What anomaly detection means is if you see spikes or dips in your real-time data, you can detect those in milliseconds by writing some special functions. Parallelized jobs, what that means is if in your job you have, in your data, if you have partition ID, you do not have to worry about parallelism of jobs. ASA takes care of that as well. Last is trusted service. We guarantee 999 SLA, and we guarantee that your data will not be lost. Even if there is a outage or any issue from customer side, there is never a data loss. And also, we guarantee that only once processing will happen. Now, let's talk about this new experience, which I'll be demoing. It's called no-code drag and drop experience. What it means is that I will be creating a streaming pipeline without writing any code. And it's very easy to learn. I'll show you how in minutes I can quickly get data in Event Hub and start processing and get into Blob. And you can run your pipeline within minutes. And what are the benefits of that? You can be very productive and you can instantaneously validate your logic. Which means while you're doing the drag and drop, there is a query getting created in the background, and you do not have to test it again and again. It just gets tested automatically, and it's super fast. So this diagram actually shows that without leaving Event Hubs, I know that most of you use Event Hubs today. Without leaving Event Hub, you can create Azure Stream Analytics job, and you can actually define where you want to send your process data to. So let me jump into demo here. All right. So this is my Event Hub, which is getting data. As you can see, these are the requests I'm getting, messages, and high throughput as well. So I go into process data, and if you've used Event Hubs, you might have seen this before, where you could process your Event Hub data writing SQL query. But now we have introduced this part, which is basically about creating a query using drag and drop, and you do not have to write any code. So there are 4 templates in this. One is talking about how you can quickly filter and ingest to Synapse SQL. The second is capturing your data into ADLS Gen 2. So as Kevin talked about how how Event Hub support capture into ADLS Gen 2, and actually using this experience, you can capture your data in Parquet format. The third is how you can materialize data in Cosmos DB. Fourth is filtering and ingest to ADLS Gen 2. And then there is a blank canvas. So I'll show you 2 demos today. One will be about how you can capture in Parquet format and how you can use the blank canvas. So let's start with Parquet. You click on Start, and it basically says you have to create a new Azure Stream Analytics job. So let me give it a name. And create it. So your Azure Stream Analytics job got created within Event Hub. You did not have to leave the service at all. Now here, I'm not sure if it's visible to people in the back, but all the configurations are already done. So there's a consumer group that you would need to select if you want to change it to anything other than default. Serialization format, I know of the incoming events is JSON, but you can select Avro or CSV as well. If you want to change authentication method, you're welcome to do that. But if I do not want to do any changes, I simply do connect. And it's showing that there is data in this Event Hub. Let's look at this data quickly. So this is toll booth data, where there is car make, the manufacturing, and other details around the car model. What time is the car entering in the toll booth, the state, toll amount that it's paying, and a little bit more details. This is a real-time data. You'll see that this data will keep refreshing. Here you can see what is the schema of the data that's incoming. So here, actually, if you see a car model, it's a nested JSON file, but you can see inside there are 4 fields. For a specific field, if you want, you can either delete from your schema, or you can rename, or you can even cast to a different data type. If you want, you can also add a field, but let's use this as it is. And I want to send this data to Blob, and this is basically capturing using Parquet. So let me select Blob here. And I have created a container for integrate. So let me select that. And let's give it a path. The serialization is Parquet. And let's connect to this ADLS Gen 2. Okay, so it looks like I have successfully connected to ADLS Gen 2, and I can also see that the data is, it'll go into ADLS Gen 2 if I start the job. So let's save this job and start it. So for starting, there are a few options if you want to understand more about them. Output start time basically means if you want your job to start producing output right now, or you want to specify some custom time. And streaming units is a computation. It defines the units used for compute and memory. We suggest customers to start with 3 and scale up and down accordingly once the job has been started. So let's start this job. It takes a couple of minutes to start the job, but you can see that your job already is listed here. You're in Event Hub instance, and you can see the Azure Stream Analytics job is listed here, the status of it, what streaming units I provided. This actually shows the liveliness of the job. So once the job starts, this output watermark will also change. And you can also open metrics that I will show you later. And you can start or stop or delete your job from here itself. So let me refresh and see if the job has started. It's still starting. It'll take probably 1 more minute to start. Let's see. While it's starting, I already have another job which is doing exactly the same thing from Event Hub loading into ADLS Gen 2. And if I go into my containers, I have this demo container. And if I go into the date, I actually see data loading in. But this is from this. I was actually working on this before this demo session. But let me see if that job has started already. Okay, so the job is running. Let's go and refresh the containers. Okay, I'm in my containers in storage account, and let me go to the container that I just created. Okay, let's give it 1 more minute, and then it'll start showing under date and time. But as you can see from the previous running job, which I had started just before this demo, there was already data that was being written. Now let me show you another scenario. This was the first scenario about how you can capture data directly into ADLS in Parquet. Let's start with another scenario, which is the blank canvas. So if I start with blank canvas, now let me connect to the Event Hub again. It's the same toll booth data, but I will be doing little different transformations on that data here. So it's a blank canvas. There is no pre-created template. The data is coming in. If you want, you can always pause or restart the data. And let me do a group by here. So I want to, my goal behind this job is that I want to create a dashboard which actually shows how many cars are coming in for grouping by on the specific model and showing on time. So let me group by and see if I can actually count the cars which are coming in. So I'll do count on make, which is the aggregation I have defined. And I will also do one more aggregation, which is group by. I will do that on count again. And I want to actually do this group by every 5 seconds. So that's where this 5 seconds is defined. If you want, you can always change this time as well. Now let's do manage fields. What this means is I actually want to make sure wherever I'm sending the data, the incoming data matches the schema of the table where I'm sending the data to. So I already have a dedicated SQL pool where I want to send data. Just to make sure everything stays consistent and this query writes data into that SQL pool, then I want to make sure that the field names are the same. So let me do that. So there's make coming in, I'll keep it as the same. And let's say the count, I will keep as car count. And the window end time, I'll name as the times. And I want to send it to Synapse here. So I'll click that and make this connection and say I want to send it to Synapse. So I configure my Synapse quickly. And I can select any database I want to send to. This is the database that I was talking about, and there is a table that I can define. Okay. So let's look at the data that's going to go into Synapse here. So as you can see here, I did little group by transformations, then I did manage field, and I'm sending that data to my output. And my incoming data has been changed to this, where let's say a Chevy model, 22 of them are going to the toll booth at this time. So, and this is what I want to plot on my Power BI. But the aim and my goal behind showing this is that it's so easy to create this end-to-end pipeline from Event Hub to where you want to send the output by actually writing zero code and literally just dragging, dropping, and doing some configurations, and you're done. You save it and you start the job. So I have one job that is already running with exact same query. And if I go into my Synapse pool where I actually am sending this data, let me see what data is coming in. And let me actually order by recent. So as you can see, there is some recent data that's coming in based on the time. Now I can actually go to Power BI. I have a dashboard that is plotting this data, and I can plot any kind of visualization. And since it's a real-time data, then you can go into advanced settings and actually do a page refresh of every 5 seconds or 10 seconds depending on your data frequency. So let's go back to the no-code integration. I want to explain a few more things here. So this was the query that I was making, but if I wanted, I could have brought in more transformations like filtering or aggregate or join, union, any of these transformations. And I could send to, I showed you ADLS Gen 2 in my first job, and my second job I showed you Synapse, and you can also send your data to Cosmos DB, and we are bringing more outputs here so that you don't have to write your code, and you can send to multiple outputs very easily. You save and start, and that's it. Now let's go to the list of jobs that are running in, sorry, where is that? Yeah. So in my Event Hub instance, I have created a lot of Stream Analytics jobs, which one is like created, another one is running. But I want to see what's going on with my job. This is Azure Stream Analytics job. So I actually open this job. You can edit the job if you want here, or you can go to Azure portal of Azure Stream Analytics, and that's where you can get more information. So let's go to Azure Stream Analytics portal and see what's going on with the job, which is running. So this job is, let it load first. Okay, So as you can see, this talks about how much percent of utilization is going on with resources. So SU percent is 7%. That means the SU that I had allocated was high. I should bring it down. But CPU is super high, so maybe something is wrong there. So accordingly, you can troubleshoot your query here. You can see that 840 input events are coming in, and out of that, 713 are being written to the output that I had selected. This is the watermark delay. There is a little bit of delay, and sometimes it depends on the events that are coming in, or it could be any reason as well. There are no backlogged events. So all the events that are coming in are getting processed, and there are no errors. So looking at these charts, you can quickly figure out what's going on in your query, and you can troubleshoot and understand how you can make the job and the query better. Right. Let's go back. So I want to talk about some of the features that we have recently released in Azure Stream Analytics. First is that now you can actually bring in your Azure ML UDF. So as I talked about, currently before this we had supported multiple types of UDFs and UDAs, but now you can do Azure ML as well. We now support increased scale, as a lot of our customers had demanded, and you can actually go up to 396 SUs per job for that. We also have auto scale because a lot of times the job is processing less data or more data depending on the logic. So instead of users doing scale up and down, we let the job do the auto scale. And the no-code editor that I just showed you, it's in preview, but it lets users create your streaming pipeline without writing any code. And we also have improved query editor, which means the query or the authoring surface we have in Azure Stream Analytics, very comprehensive. You can bring in your inputs and outputs very easily without writing any code. And what's coming is we are targeting 30% performance boost, very highly demanded feature. We are bringing Postgres and ADX output for Azure Stream Analytics. We're also bringing job diagram, which makes it super simple for you to understand if your job is parallel or not, or you want to improve any logic, or you want to do repartitioning, whether it's embarrassingly parallel or not. So it makes it very easy to troubleshoot your queries which are stuck. And we are going to bring in more user-assigned managed identities. And we will do a GA of autoscale and no-code editor. Okay.
All right, so, I mean, I'm super excited about this stuff. You know, being able to take your real-time data and actually transform it without writing any code, all integrated into a single portal, you know, makes your lives easier and you know, reduces the number of errors you have and your more, you know, rapid time to actually getting deployed. You know, real-time data is, you know, kind of the future of, you know, how we access all that data that's floating out there, the torrent of data. And hopefully with these tools, we can help you make that easier for you guys as you do your integrations. You know, we'd love to talk to you. These are great ways to reach out to us, you know, either through emails if you want to connect to the product teams, or if you want to give us feedback and you want to vote for a particular feature, right here are the links to go and vote on those. And I think that's it.
Yes.
All right. Thank you, everybody.
Thank you so much.
Covey.co